Hey everyone, and welcome to a new video on this channel, this time about Kubernetes service accounts. Now, before we get our hands dirty, let's take a step back and look at secure access to the API server. What are the pieces of that? Now, first of all, of course, you have to authenticate to the API server. For a regular human, hopefully also yourself, that will be through a user or a group. But if applications need to authenticate to the API server, we typically use a service account for that. Now, after you authenticate to the API server, you also have to have the proper authorization to do what you want to do. For example, suppose that our service account needs to list pods in a namespace. Then we need the proper roles and role bindings, we'll see more about that later, that give us that access right. And another way to secure access to the API server is by using admission control. These are things like webhooks, which are called when you do a call to the API server, and the webhook then decides, looking at your call, if what you want to do is allowed or not. This video is not looking at the admission control part in detail. Now, how can we authenticate to Kubernetes? How do we do that? Well, this is done via plugins, and there are several different ways that authentication can happen. Probably the most common way is using client certificates. The certificate is typically in your kube config somewhere, and that's how you authenticate to the cluster. In most enterprise environments, you will more often than not link with an external identity management system. That's done through OpenID Connect. For example, in an AKS environment, so Azure Kubernetes service, it is very easy to integrate that with Azure AD, for instance. So that makes it easy to use users and groups defined in that Azure Active Directory. Now, for this video, we'll focus on the second option, and it is using an authentication token, typically a Java or JavaScript web token, or a JWT, the JWT, right? And that is mostly used for service account authentication. It's important to realize that Kubernetes has no API to define users and groups. These users and groups have to be defined externally. For instance, when you're using certificates, the users and groups are defined directly inside the certificate. If you're using something like Azure AD and you connect it via OpenID Connect, then the users and groups are defined within Azure AD. Now, this is different for a service account. Kubernetes does have an API to define service accounts, and they are created in a namespace, so they are namespaced objects. Now, what is the service account used for? It's used to allow a process in a pod to access the Kubernetes API server. Now, if you've never defined a service account, or you never thought about this, you should realize that there is something like a default service account. If you check inside a namespace and you list service accounts, you'll find that there is a default service account. But that default service account has no access to the API server. It hasn't been granted specific access rights. So if you are creating an application and you know that a process in a pod needs to connect to the Kubernetes API server, you should create your own service account. Never give access rights to the default one. Of course, when you create such a service account, you will then need to give it the proper access rights, and we'll do that with roles and role bindings. I will see more about that in a moment. The service account can then be used to obtain an authentication token and a CA certificate to connect and authenticate to the Kubernetes API server. Now, you're probably thinking, how does that work? Well, automatically your service account gets a Kubernetes secret as well, and the secret contains this information. But that will become more clear when we start working with it on the cluster. As a side note, if you deploy Kubernetes in Azure and you're using Azure Kubernetes Service or AKS, you might want a process in a pod to to access the Azure APIs as well. Now there's a different mechanism for this, which is the Azure AD pod identity, which is totally separate from this service account that has Kubernetes API access. But those two can actually coexist. So you can create a service account and use that inside the pod to connect or talk to the Kubernetes API, and at the same time use AAD pod identity to talk to the Azure APIs and do whatever you need to do there. Right, now let's get started creating and working with these service accounts. Okay, let's get our hands dirty, and we'll start with just running an Alpine pod. We didn't specify a service account for this pod, so the default service account should be used. So I'm running that Alpine pod, and I'm getting a shell to the Alpine pod. Now we can go to the following folder, that's var, and then run secrets kubernetes.io service account, because this is where the secret that's associated with the service account is mounted. And that secret contains three pieces of data. In this case, what we want to work with, or what we need, is the ca.crt and the token. If I cat out ca.crt, this is a standard certificate. And we can use this to validate the TLS connection to the Kubernetes API endpoint. Yeah. For example, if you're using curl and you don't have to use the -- insecure option to create your or make your connection. Let's clear this out and do ls again. We also have the token, and this is actually this JWT or JWT that we get, and this one contains everything what is needed to properly authenticate to the cluster as this default service account. Now, what we can do here is we can take this token. So I'm going to just copy this, and I have on my machine here, I have the JWT or the JWT CLI installed. I can run that and then paste the token after that. And what you'll see is that indeed this token contains the following header that you'll see here, but the payload is indeed, it's a Kubernetes service account in the namespace default. The secret that's associated with the service account is indeed default token and then this value here, and the service account is indeed default. So it's clear that the token contains information to identify the service account that is being used here. Let's create a service account, and I'm going to use the kubectl command here, which is alias to k. We can just use create service account and then the name of the service account. If you want to know what the YAML has to be that you have to submit to the API server, you can just use dry run with the option to output to YAML, and this would be the manifest to create the service account. I'm going to use kubectl anyway, so not using the YAML, and create the service account. With kget.sa, I can see the listing of service accounts, and we see that app.sa is now created next to the default one that you always get in a namespace. We also know that we get a secret now. Secret contains 3 pieces of data. You can see this is linked to the app service account or app.sa service account. Let's check out the secret here and look inside the actual YAML and look at the data pieces. So the data inside the secret is ca.crt. We have a namespace and we have the JWT token. Now, if I'm selecting this token, you should know that this is base64 encoded, as secrets are in Kubernetes. So we can just echo this and pipe it to base64-d, and that decodes the value. And here it starts with EW here, or EY, actually not W. I'm just gonna copy this and I'm going to pass this to the JWT application I installed on my machine. You can just do npm install, so you need npm for this, and then the jwt-cli package you have to install, and you install it globally with the -g. And I just want to see what's inside this token. And here it is. The token, the payload, let's focus on that, contains the information that this has to do, that this is linked to our service account with the name app SA. It has a UID as well, and it has all kinds of other identifying information that Kubernetes will need later to decide what are the roles assigned to this service account. So to know what this service account can do at the API level. So now that we know that we have our service account and we have our secret is there, we need to create a pod, or we need to have a pod where we specify that we want this service account to be used. Yeah. How do we do that? So how do we say, don't use the default service account, but use the app SA service account? Well, in my case, I have a deployment. I will just cat this out with the cat and then deployment SA YAML. And what you'll see here that in the spec of the pod for this deployment, you'll see that there's a service account name section. And there we specify that we want to use the app SA service account. Now this deployment just deploys one container, replicas one of the image by this user using Alpine curl, because I want to use curl to basically do a request to the API server. Now we have to first get these pods or this pod running. So we're going to use k apply -f and then deployment -sa YAML. This has now been done. Let's clear this out, do k get deploy, and there's a deployment. Let's do k get pod, and there we see we have our Alpine deployment pod running. Yeah, it's ready and it's in the running state. I've now started K9S and I'm on this the pod from that Alpine deployment, and I can use D to describe it. So let's just do that. Let's do D and let's check out a little bit lower here what the mounts are. And as you can see, the secret, which is app SA token, as we have seen before with this value also appended, has been mounted on the file system in the var run secrets and so on, the service account folder. So that means that our application can now access the certificate, but also the token to do authenticated calls to the Kubernetes API server. Let's just try and do that. I'm now in a shell of that pod that we just deployed, which has the secret mounted for our new service account. So we can now grab a reference to our ca.crt file just by saving that into an environment variable. And the first thing we can try is we can do a curl to the Kubernetes API endpoint. So we can do this as follows, and with the --ca cert, we can tell curl, hey, you know what, you can verify the full TLS connection. You can trust the certificate that is presented to you by the Kubernetes API endpoint, right? We're going to use a get to the HTTPS :// Kubernetes, and Kubernetes is just a service defined inside your cluster basically, and that gives you access from inside pods to the API server. Now, if we do this, we'll get the following error. User anonymous cannot get that path, because indeed I did not identify who I am. I have to specify this token for this to work. So let's grab the token as well, which is also mounted, as we have seen earlier, via the file system. To get that token, I'm going to use the following command. Now let me just grab that and copy and paste it into this shell here. And it's important here that you don't just get a reference to the file. No, you have to cat out the contents of that file and store that in the variable, in this case, the variable token. If you forget that cat and just use the same approach as with the ca.crt file, that won't work. Now let's go back to my copy and pasting again here, and I can indeed use the following command now to specify the same thing as before, but we're passing also an HTTP header, which is the authorization header, and we specify the bearer token to authenticate as the service account app SA. Let's do that. And now in this case, we get this response, which is expected. By the way, what happens if you don't specify the CA cert? Just to give you that as well. If you remove the CA cert here, curl will actually say, well, this is not secure. I cannot verify the certificate I get from the Kubernetes API endpoint. Now you can specify -- insecure to just tell curl, you know what, don't worry about it, right? That would also work. Great. That means we now have used our service account. We've used the secret that is mounted inside the pod for this service account to do a successful authentication to the Kubernetes API server. Although we can successfully authenticate to the API server, we cannot really do that much because we haven't been granted the correct access rights to do anything. Suppose I want this service account to be able to list pods inside the default namespace. Well then, according to the RBAC system inside Kubernetes, I have to create a role and a role binding. First, the role. With a role, you give that role a name, and then you specify the verbs that you are allowed to use and the resources you're allowed to use those verbs with. So in this case, I want to do a listing of a type of resource, which is pods. Okay, now to know what kind of YAML I need to submit for that, we can again use the dry run client and the output to YAML, and this would be the YAML I have to submit to the cluster. Now, I'm not going to do that, so I'm going to create the role directly, and I'm going to create it like this. That's the role. But of course, the role itself is not enough. I need to bind this role to the service account that I created earlier. You will use a role binding for that. Now, we'll use the same approach as with the role. What we'll do is we are going to use create role binding, and I think I did it. Yeah. I made a small mistake here, so I'm going to use dry run -o YAML. That's a pasting mistake, but I'm going to leave it in the video. Happens to all of us. So create role binding. This is the name of the role binding. I'd like to bind the service account, which has to be named namespace : service account name. I want to bind the service account to the role pod lister. Now, to know what kind of YAML I need to use for that, I use this, and indeed I should use dry run is client because that is deprecated. So this is the correct command, and this would be the YAML I need to submit to my cluster if I want to create this role binding via a manifest. I'm not going to do that now, so I'm going to just create the role binding from the command line, and this is the role binding that is now created. Yeah. So if I'm now doing get role, you'll find that there's a role in the namespace called pod lister. And if I do get role binding, I have a role binding called app-sa-podlist. This should be enough to go inside the pod and to basically do a curl to the API that gives me a list of the pods in my namespace. Let's just do that. And to do so, I'm going to show you all the way how it's done. I will use K9s, which is easier in day-to-day work. So I'm going to go here to my Alpine pod. I'm going to grab a shell in the Alpine pod. And I want to, just as before, I want to get the certificate authority and the token in environment variables. So just as before, I'm saving the CA here. I'm also saving the token for my service account. And now I'm going to do a curl command to give me a listing of pods. Let's do that. And we'll do it with this command over here. Same as before. So a curl, we specify the CA cert. We do a get. By the way, there is no list verb, of course. We use list in the role, but we use get in the actual curl command. And in this case, I want to list the pods in the default namespace. So I have to use behind API /v1/namespaces /name of the namespace and then /pods. And of course, I'm going to authenticate and present my token to the API endpoint. And I'm using head here as well. I will actually specify the number of lines I want to see, like 20 lines I want to see, because it's quite a long list that you'll get here. Let's see if this works. And indeed, we see that curl has done the request, and I'm getting an array of items back from the API server. And this is basically the first pod that I'm getting back. Metadata name, this is my Alpine pod. If there are more pods, of course, they will all be listed. You have just seen how to do this request with authentication to the Kubernetes API server using curl. Most of the time, though, you will write some software in some kind of language that does what you need to do. For example, if you write code in Go or you write code in Python, you'll probably want to use these techniques from within that application. Now, you don't have to do this all by hand here, because the Kubernetes client, in this case the one for Python, it has the following load in cluster config option here, and that basically uses this the same approach to get the token from the secret mount and so on to properly authenticate to the Kubernetes API endpoint. So we use this load in cluster config. Then we get the client, which is using the core v1 API. And then here you see that it does a list pod for all namespaces, basically. So you would need a different role binding here at cluster level to do this across all the namespaces. Yeah, so keep that into account. We've seen it with curl. That explains how it works under the hood. But of course, there are some abstractions in the languages that you use, like in this case with the Kubernetes client in Python. And it's similar for Go and other Kubernetes clients. And with this, we have come to the end of this video about Kubernetes service accounts. Thanks for watching, and see you next time.